Hello and welcome back to Algebra. So today we are going to take a look at multiplication and division of rational expressions. Let me see, 7.2. Multiplication and division of rational expressions. So yesterday we talked about simplifying and canceling. Right? Today the goal is to use that again, except now it's going to be two of those rational expressions, and they're either divided or multiplied. Now, these expressions cancel, which is great, and that allows us to work with smaller values, right? So multiplication and division of rational expressions is done the same way as multiplication and division of fractions. So we have canceling involved, we have multiplication is across, and the division was you flip the second one, right, and you multiply instead of dividing. So the rules are going to be the same as before. So for multiplication, we will just go straight across, cancel if you can, and for the division we'll have a over b divided by c over d would flip d over c, and then you'll have AD over BC. Again, cancel if you can. So this is what we are dealing with today. And if you know how to do this with fractions, then rational expressions will be no different, except you will just have to be careful to cancel the particular terms. So remember how you had, let's say, 3 over, 16 times 12 over 7. So you are supposed to multiply across, right, like this. But we can cancel. We cancel 16 and 12 by 4. We get 4 and 3. And now when you multiply, you get 3 times 3 over 4 times 7. Nothing else cancels. For 9 over 28. And so we have this as our multiplication. But today we care about expressions, which means now you are going to have something like this. X minus 1 over 4x times x plus 3 over x minus 1. Now, since we are multiplying across, we should be multiplying these two, but in this case, we see that these two terms are identical, they cancel, and your answer is just x plus 3 divided by 4x. That's it. If you have 2x plus 6 divided by x plus 3, let's say, times 6 over x minus 1. You can literally put anything. If you are able to cancel, you cancel and then multiply whatever is left over. So this problem is going to be 2x plus 3 over x plus 3 times 6 over x minus 1. These guys cancel because they are the same, and we just get 12 over x minus 1. Every problem is the same. Factor all. 2. Cancel what we can. 3. Multiply across what's left. That's all. So here is me factoring. Here is me canceling. And multiply across. Now this one is just 1 times x minus 1, so this stays as x minus 1. So every step is always followed. Let's see some spicier cases. 4 divided by x squared plus 3x plus 2 times x squared plus 2x plus 1 divided by 8. Step number 1 says factor everything. So that's going to be 4 divided by, and now this one is x plus 1, x plus 2. Right? How do we know this? Because the factors of 2 are 1 and 2. When you add 1 and 2, you get 3. So we're good to go. X plus 1, x plus 2. Do we know this from chapter 6? The other factoring here, also from chapter 6, is going to be x plus 1 times x plus 1. You can also write it as x plus 1 squared, divided by 8. As long as you are canceling 1 on the top and 1 on the bottom, you are doing it right. So these two cancel. 4 and 8 cancel by 4. We get 1 and 2. So what's the leftover? The leftover is x plus 1 divided by 2 times x plus 2. Leave it in a factored form, right? Because you can write 2x plus 4, but that's not simplified fully, right? You want to leave everything in a factored form. The simplest possible case. Multiplication is just done across, but make sure you cancel, factor and cancel first. Let's pick up more from the textbook. Problem 40 looks good. X minus 1 divided by x squared times x squared divided by x squared plus 1. This term can't be simplified. These terms can't be simplified. This term cannot be simplified either, because that needs to be a minus in order for it to be difference of squares. This is a sum of squares. That's not factorable over real numbers. Therefore, no factoring. Okay, so what's the same? Well, x squared and x squared are the same. By the way, these x squares are not the same, because the one on the bottom has a plus 1. We are not allowed to cancel within addition. You can only cancel identical terms. So x minus 1 over x squared plus 1, and that's it. There's nothing else we can do. 42 has more spice to it. Z squared over 9 divided by z minus 5 times z minus 5 divided by z plus 3. Now, this one here is the difference of squares. And if it's a difference of squares, that means, right, that's a sum of squares, that can factor. If it's a difference of squares, that means you can factor it. So that's z minus 3, z plus 3. When you use difference of squares formula, which we memorized in chapter 6, z minus 5 times, divided by z plus 3. Alright, so now z plus 3 cancels z plus 3, z minus 5 cancels z minus 5, and the only thing that survives is z minus 3 as the answer. That's it. One more for multiplication, and then we'll jump to division. Say 44 looks good. Y squared minus 4y divided by y plus 1 times y plus 1 divided by y minus 4. So remembering the steps, we are supposed to factor everything. These guys can't factor anything, that's already done. But this one here, we can use GCF to pull out y. So y minus 4 is a leftover, divided by y plus 1 times y plus 1 divided by y minus 4. Y minus 4 cancels, y plus 1 cancels, and the only thing that stays around is this single y, because everything else canceled. Everything else cancels into a 1. The reason why canceling works is because you are dividing a value by itself. That's why they have to be the same. You see, 3 divided by 3 is 1. 10 divided by 10 is 1. Y plus 1 divided by y plus 1 is 1. Z plus 3 divided by z plus 3 is 1. So when we say cancel, actually what happens is they divide into a 1, and when you multiply this y that has nothing to cancel with, when you multiply this y by 1 from the red pair and the 1 from the blue pair, you get y times 1 times 1, and it's just y. So you are not canceling these expressions into zeros, into nothingness. You are canceling these expressions into a 1, and then y times 1 is y. So that's the idea about canceling the fractions, right? You're canceling fractions, but you are actually, what you're doing is you're dividing the two values, and that's why they must be identical, right? One of the things that students get confused with, and you have to be very careful with this, is when you have, let's say, x squared plus 3 divided by x squared minus 1. We cannot cancel anything. In this problem. There's nothing you can do. You will say, but wait, you have x squared on top and x squared on... Yeah, we do have x squares, but they are added to 3 and subtracted 1, so they are different terms. They cannot cancel. You see, you can try this. You know, say x equals to 10, right? To prove this, just say let equal 10. What do you get? In this case, you will get 10 squared plus 3 divided by 10 squared minus 1. And when you compute these, you will just get 10 squared and 10 squared, so that's 100 plus 3 divided by 100 minus 1. That's 103 divided by 99. And that is going to be some number. 1.0 blah 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 blah. Well, let's see. 103 divided by 99 is going to give you approximately 1.04. Now, students who don't pay attention and don't learn, they cancel x squares. Well, if you cancel x squares, then you just have a 3 divided by negative 1, that's negative 3. That's not the same. So you see it's wrong, right? If you just cancel x squares. You are not allowed to cancel when you have addition and subtraction. You can only put them in a block and cancel as a block only if there is another block that it's absolutely the same. That's the way the canceling works. So we have to be careful not to get into the trap of, cancel everything that looks almost the same or whatever. You are only allowed to cancel within multiplication, and one has to be on top, one has to be on the bottom, because they're actually dividing into a 1. They have to be identical, I already said, and you cannot cancel parts of these. You can only cancel the whole term. Division. Now, division is simple if you understand multiplication, obviously. If you have, let's say, 5 over 2x divided by 10 over x minus 4, your job is to first flip this, right? And then you will factor if you can. Then you will cancel if you can. This one divided gives us 1 and 2. And then you just multiply across. So you technically change every division problem, you change into multiplication problem and just follow multiplication rules. So that's x minus 4 divided by 4x. That's it. Let's take a look at another example. This is a little bit spicier, but still okay. X squared minus 9 divided by x squared plus 4 divided by x minus 3. Now, I remember a couple of times in class asking you, what if I don't have a second fraction? And you were the ones who told me, I'll just put over 1, it'll be fine. So we create these fractions, and then we flip into multiplication. So our first step is to make multiplication out of it. And then we can just follow multiplication steps. So division has one extra step. And that one extra step is the flip. Right, so you flip this into multiplication. That's all. Once you have multiplication, you follow multiplication steps. Factor everything. That's x minus 3, x plus 3, because it is difference of squares. X squared plus 4 cannot factor because it's a plus here, right? You must have minus in order to factor. Times 1 over x minus 3. What's the same? X minus 3, x minus 3, and you get x plus 3 divided by x squared plus 4. That's it. Nothing else that you can factor here. You can't cancel x's because they are buried within, 3's and 4's and so on. So we're done. This is it. We ended the problem. And then some spicier cases, obviously, where you would have to involve more factoring. X squared minus x divided by x squared minus x minus 2 divided by x over x minus 2. The first order of business is to flip into multiplication. And then factor what you can. The top is a basic GCF factoring. So we have xx minus 2. Xx minus 1. So when I pull x common, when I take x, 1x stays behind. And when I take the x out, 1 stays behind. The bottom is going to have negative 2, which factors into 1 and negative 2. When you add them, you do get negative 1x, which is the middle one, which is great. So we know that this is x plus 1, x minus 2, times x minus 2 over x. We cancel x minus 2, and we cancel x. What's left is x minus 1 over x plus 1. And these guys don't cancel. Let's take a look at least 2 of these homework exercises. If you know factoring, if you are really good at factoring, this section is a joke for you. It's very short. There's nothing else other than these 2 things, right? So let's see. This problem 59 says y squared minus 9 over y squared minus 25 divided by y plus 3 over y plus 5. Okay, not an issue. Not an issue. All I need to do is to flip into multiplication. So our step is always to flip into multiplication. And then we cancel. So y minus 3, y plus 3, y minus 5, y plus 5. And then we have times y plus 5 over y plus 3. So we had 2 special factoring over here, right? From 6.4. 2 difference of squares. We know the formula for that. We'll just quickly factor it. And then cancel what we can. Y plus 5 and y plus 5 is gone. And y plus 3 and y plus 3 is gone. So what's left as the answer is y minus 3 over y minus 5. And remember, you can't cancel these because of the minus 3 and minus 5. You cannot cancel y's. You can only cancel where each one of the entities here, you have 3 entities on the top, right? Each one of them is multiplied, right? This would be in a parentheses, multiplied, as you can see, multiplied into the other ones. So you can only cancel when it's multiplication. Let's see what else. Problem 64, and that will be all, right? We have z squared plus 12z, plus 27, cross your z's so you don't confuse them with 2's, z squared minus 5z minus 14 divided by z plus 3 divided by z plus 2. So what do we have in this case? Well, the first order of business is to make it multiplication and then just follow multiplication steps, which are factor, cancel, multiply. So we have z squared plus 12z plus 27 divided by z squared minus 5z minus 14 times z plus 2 over z plus 3. You see that's flip, right? Now, some of you might have a question. Can I just, instead of copying this, can I just have it factored there and save a step? The answer is yes. If you want to do 2 steps in one shot, go ahead. We have to factor 27. That's 1 and 27, 3 and 9, and that's it. But 3 and 9 add to 12, so we're good there. We have z plus 3, z plus 9 divided by, and now I need negative 14. That's going to be 1 and negative 14, 2 and negative 7, 8, 9, 10, nothing else divides. I need negative 5, well that's this, which is great. So I have a z plus 2, a z minus 7, and then I have z plus 2 over z plus 3. So we cancel z plus 3 with z plus 3. We cancel z plus 2 with z plus 2. And we get z plus 9 divided by z minus 7 as the answer. You cannot cancel those z's because of plus 9 and minus 7. They have to stay as is because they represent different numbers, right? The one on top is always 16 by 16 larger than the one on the bottom. So that's something that you have to keep in mind. And believe it or not, that's it. This is the whole lecture. Multiplication and division. We're going to add and subtract rational expressions tomorrow at 1. And then on Thursday will be the last lesson for algebra. Next week will be all exams and reviews for the final. Make sure you read the announcements that I'm going to post on the Canvas. Not to, miss any of the exams and things. And the course is over by May 12th. So 2 weeks left, right? The final will be in 2 weeks. I'm now going to check emails and see what's going on over there. Bye.